Good afternoon. I am Raju, by the way, not he. Okay.
Thanks for clarifying that, Raju.
Indeed. So I am Raju Gottumukkala. I'm an applied AI professor at University of Louisiana at Lafayette. I was born in India, but I've been in Louisiana for the past 25 years. And I've never left Louisiana, and I've never left university. Okay, so started as a student and have been a professor. I did spend some time at Xerox and Oak Ridge, but university is home. So I've done some work in cybersecurity of smart charging systems through a DOE grant in collaboration with Idaho National Lab. And most recently, I lead the Center for Applied AI, where the mission of the center is really to help with advancing applied research in AI, number one. And then number two, workforce development, right? Helping not only our students, but also local businesses and workforce really upskill with AI, number two. And then third is also facilitating economic development, really helping really the small and medium businesses around the area just to demystify AI. And a lot of companies want to start AI, but they don't know where to start. So we've created the Center for Applied AI with that mission. And today it's an exciting topic, right? Which is AI automation and cybersecurity. Right, three very, very relevant topics, and how these three areas are really changing and transforming transportation in a big way. So that's about me, and I'm excited to join here with my colleague, Jay. Would you like to introduce yourself?
Absolutely, absolutely. And we had started talking last week, and already we're having a great conversation, so we figured even if no one showed up at the last panel of the day, we'd still continue a great conversation. This was originally going to be a fireside chat, but not only was there no fire, but it's so cold in here to have one, everyone would come up closer and probably just try to warm up. So my name is Jay Lau. I'm with Bot Auto, strategic advisor. I have been in trucking for 30 plus years of my career. I, like John, started in the lowest possible level in trucking, which is loading and unloading trucks, which I love because so as a kid, I loved big trucks too. And I found my way to automation really in 2018 because I was getting frustrated by the lack of innovation in transportation. I had had the pleasure of, on the shipper side, working with fleets on alternative fuel sources, but most of the shippers that I had talked to really didn't seem to care about transportation. It was becoming a procurement exercise and not something as a differentiator. So when I found my way into automation, it was brilliant because over the last couple of years, this proliferation of AI has gotten to the point where my 16-year-old daughter uses the terminology like large language model, artificial intelligence, and she refers to me as having DI, which is dad ignorance when it comes to a lot of things. So we're going to have a conversation today. Hopefully you can take something out of it. We'd love it to be conversational, so please feel free to just raise your hand, ask a question. But rather than letting a trucking guy explain AI, I'm gonna pass it back over to you, Raju, who's going to be able to articulate it much more eloquently than I could.
Yeah, absolutely. So when we talk about AI, so AI is not new, right? It's been around for actually more than 40 years, believe it or not. But I think the most recent AI is really machine learning, right? Which is really creating these models that actually learn from data. Okay. In the transportation industry, AI ML has already been in use, right? There is the very matured AI, which is the stuff that is already in the cars. Like, for example, your auto lane correction systems, your backup cameras when you're trying to back up your car, it warns you saying that, look, you're about to hit something. So those are computer vision systems that have been around for a while, and also your driver monitoring systems that warn you if you're about to fall asleep. So we have one in our lab, a simulator actually. So those are computer vision systems. They've been around for a while. And there is also a lot of work in predictive analytics. Like, for example, your route planner, whether you're using Google Maps or some other maps, it actually uses AI to give you the best route possible. Taking into account the historical traffic along that route, whether it's a weekday or a weekend, and taking all the live traffic information. So all those models actually use machine learning/AI and have been used in quite some time. And this is not just for the passenger cars, right? I mean, I've heard a lot about fleet management, for example. They use this predictive analytics model for fleet management. Also predictive maintenance. Like if you have a huge fleet, and let's say this is a utility vehicle that you're using, going and doing, I don't know, fixing something like your electric poles. You don't want these vehicles to break down when they're on the job, right? So companies are using predictive maintenance to actually maintain these trucks before something fails, right? So all of these are classical machine learning that have been in use for 5 years now. And I think, we're all familiar with these things, right? I mean, and then there is the ChatGPT type large language models. Well, these are models that are really trained to communicate with humans, okay? Which means you can chat with them and they respond back to you either in text or in voice. And this has really taken the world by storm, right? Because there is no longer a technology barrier, there is no longer a language barrier. You can just speak to these large language models. And surprisingly, these models just work very similar to your auto text completion feature on your smartphone, right? Except that your auto text completion is just completing the next word, but these can actually complete, whole large sentences and even write books for you. Okay, so these work quite well, but I wouldn't use large language models for anything that is related to safety, right? Because they have some limitations. I mean, these are black box models, number one. They hallucinate, right? One of my favorite word. They make up stuff, even if it is not accurate, with so much confidence. So again, that's the large language models, your ChatGPT, Claude, Gemini, and there are a bunch of those. And then third is this really emerging AI, which is some of these semi-autonomous vehicles. They're also trying to make this AI run locally, which means you don't have to send all your data to the cloud. Okay, your model actually runs in your vehicle in a small computer. Okay, so there is edge AI, and then there is also privacy-preserving AI. So we're doing a lot of work on the healthcare side, where in order for you to build really good models, good ML AI models, you have to train them across multiple demographics. Because you don't want this model to just work well for one demographic and not work well for another demographic. But in order to create those generalizable models, you have to put all the data in one place and train it. But organizations are not willing to go and send the data out of their organizations, right? Because of HIPAA compliance, confidentiality, all of those constraints. So there is this new area of something called as confidential AI, which is just keep your data local. You don't have to share it, but you just send the model, make it train, get the parameters out, and in a way that you can't just go back to the source data and so on. So there is this confidential computing area and so on. So this is really the emerging AI, and there is also this multimodal AI, which is not just using, this is very similar to the difference between Tesla and Waymo, right? So Waymo uses both the LiDARs and the computer vision sensors to train their model and to understand the vehicle surroundings, whereas Tesla wants to just use cameras, right? So anyway, so that's the emerging AI. And then there is this future AI, which is about making this AI more generalizable, more smart, and making these cars and vehicles and all of these like fully autonomous and so on. So again, I'm coming from an academic side, so I don't want to bore you with all this terminology, but I'll hand it over back to Jason, right, who's really coming from the industry side, and perhaps, Jason, you can give us a little bit of insight into maybe starting with where is the biggest ROI for this AI, ML in the transportation industry, if they choose to go in that direction, if you can help us understand that.
Absolutely. And to build upon your point about not always trusting large language models, I'm not sure if it heard you earlier, Blake, but when I got a voicemail from a telemarketer, J. Lau came across written as cheese and low. So it's not perfect yet. It doesn't know that I'm not a delicious condiment put on food for lunches and hotels. The practical applications you were talking about earlier, one of the things that the founder of Bot Auto, Ph.D. Ho, who I've had the privilege of knowing for several years, says, software ate the digital world and it choked on the physical one. And the problem with technology is technology for technology's sake does not solve the fundamental physical problem you're trying to solve. In transportation, the use of AI is predicated on what am I looking to solve? Is it route optimization? Is it energy consumption or base vehicle fuel usage? Or is it all the way to the emerging AI that Raju was talking about related to self-driving? So a couple of quick points around that. For those that aren't familiar with self-driving vehicles or in general self-driving, maybe just quick show of hands to force that everybody's blood is still moving. Has anybody ever ridden in a self-driving car? This is fantastic. So you've heard the terminology of a Waymo. Everyone is certainly, if you have X or have ever opened a tweet, you know that Elon Musk is developing full self-driving. These technologies for a passenger car are solving the practical problem of mobility. So in the future, John's organization is going to have the opportunity to work on self-driving vehicles that most likely are electric. Nearly all of the self-driving cars are, because it's easy to have a car that goes back to a depot every night that can charge, and the maintenance is actually easier. It's solving a mobility problem. The difference in trucking, though, is we always say the freight doesn't complain. And from a trucking perspective, the goal is to move as much freight as possible between point A and point B as efficiently as possible. Mark Roth mentioned yesterday, the idea of getting 10.5 to 11 miles per gallon. In my car, if my 16-year-old was driving, I would say, my goodness, how were you driving that poorly? But in an 18-wheeler, that's exceptional. And when you think about the emerging AI that my company is developing for self-driving trucks and the application, it's to make every one of those trucks the best driver, every driver. So we have the predictive analytics of not having to worry about Raju may drive differently than me, even as a team. Everyone drives the same. Now with that, the fundamental understanding of what AI can do is beyond driving. It is technology we're using today for dispatch agents that are actually answering calls from our customers and giving them an update as to where the load actually is. But no one's actually answering that phone. The AI agent is using data that we have in our system to share where that vehicle is. These are practical applications that today AI is being used. And maybe one that I think is just super interesting fundamentally when it comes to alternative fuel vehicles is 15 years ago when I was working with a fleet in Florida around natural gas deployment, there was so little data around capability of the vehicle. I couldn't share a breadth and depth of knowledge. Whereas now, the ability to absorb that data from an electric vehicle and consume it and provide a clear, simple, in my language, understanding of how that vehicle performed, that is tremendous for a fleet manager, for a business owner, for an investor looking at a company.
Oh, that's awesome. Jay, can you also break this autonomy into different levels? Because every vehicle has some type of warning system today, isn't it?
Yeah, yes.
If you can break down that, these different levels of autonomy, all the way from the very basic to the fully autonomous vehicle and where the industry is, I think that would be helpful. Thank you.
Happy to. And this is one of those, if you take it away, it's probably not that exciting at a cocktail party, but at least it's something you can share with somebody and say, I learned a lot about one terminology that I didn't know before. The Society of Automotive Engineers classifies levels of autonomy in a vehicle 0 to 5. 0 being zero autonomy or autonomous help inside the vehicle. I always tell people a level 0 vehicle is something like a 1960s Mustang. Probably doesn't even have power steering, but it's a lot of fun to drive. But push comes to shove, there's no technology keeping you in the lane, speeding you up or slowing you down. Level 1 is your traditional cruise control. Level 2 is more lane keeping and cruise control. When you get to level 4, I'll get back to level 3 because it's a bit of a middle number. When you get to level 4, it's the first level that defines the vehicle movement without a human inside the vehicle to control it. So, depending upon whether you believe that full self-driving is real, I don't own a Tesla, so I can't comment on it, but the expectation would be that if your vehicle is level 4, you don't have to pay any attention at all because it's not going to ask for your help. Level 3 is that middle level where it's almost good enough, but it may alert you and say, I need help in this situation, which is where most people in our field say it's just the most unsafe of all. Because you've got such confidence it can do what it needs to do, but it may actually ask for help. Level 4 being the first level where it drives without a person in it, but in what we refer to as a operational design domain. Same route, same weather, same highway. Level 5 is, my personal perception, decades off, anywhere to anywhere the way that we operate a vehicle today. Jump in it, drive across the bayou, back on the interstate, head to Arkansas, drive to Alaska. That is level 5, where the system has the computational capabilities to know everything and everywhere. I only say it's decades out because the requirement, like you said, to locally have that on the vehicle, just exceptional computation requirements.
Yeah.
So, we are developing as Bot Auto, as many of the companies in the trucking space are level 4, so a terminal to a terminal. I tell people it's similar to a railroad. Goes from point A to point B. There's a station at either end. That's where the freight gets picked up locally and delivered locally. And that is how the network is going to develop until the technology is capable.
Okay, so is there a driver in the vehicle when you're getting from point A to point B, or it's completely autonomous?
Yeah, it's a great question. So we have deployed our test vehicles without drivers in them, so fully driverless level 4. There are 2 companies in the space that are currently doing level 4, no one in the vehicle. Kodiak Robotics, which is doing it in private infrastructure in West Texas. And I paused there for a minute because my prior employer, Aurora, is out on the interstate between Dallas and Houston operating, but their OEM partner requires a human being in the vehicle, but they're not interacting with the vehicle. So Aurora likes to say that it is fully driverless, but there is someone technically inside of the vehicle. So these are not science fiction projects any longer. They are out there in a practical environment solving a small part of what is a larger network.
Okay, so I own a Tesla, and I've owned it for 3 years now, and I've been observing how they've been pushing these software updates out, and when we first bought it, it used to get confused with shadows, right? I mean, so anyway, there were so many issues, and I saw huge improvements over the past years. So if you don't have any driver, how well do these semi-autonomous or fully autonomous fleets work in the interstate when you have dust, when you have abnormal weather conditions, when there is like something unpredictable that happened on the road? I mean, how do these work? I mean, have you guys thought about how are you guys thinking about this? I'm sure you guys thought about this, but
yeah. So one of the first companies I worked for in autonomy was based out of Arizona. So dust and wind was a thing pretty much immediately because you don't have an option; it just happens. Technology has gotten tremendously better, but what I would say is that my company is no different than others in this space. Multimodal perception, modality, is how you win the day. And that is using camera, LiDAR, which is essentially a spinning radar creating a three-dimensional image, traditional radar and ultrasonics, and then also using the capability for listening as well, specifically for sirens and for emergency vehicles. Now, there's a couple of interesting things about self-driving vehicles that most folks don't talk about, mainly because in the passenger world, they're not really a concern today. Anyone who has been next to an 18-wheeler at 80,000 pounds going 65 miles an hour, the question always comes up of, what about a deer? What about a shopping cart? What about Jay on a horse? An interesting statistic in the trucking industry, if anybody's worked in trucking, has a CDL, been with fleets, the common perception is that you are in your lane giving as much distance as possible so that you can avoid being in a bad situation. In the event a situation occurs, a deer jumps out, a car pulls in front and you're unable to stop, you drive through the obstruction. Now, I've worked with fleets over the years that have had drivers that have done that to avoid a swerve and hurting other people, and they've lost their life because of it. I know very few humans that would be willing to make that kind of a sacrifice, but dispassionately, when the vehicle is already giving distance in a way that humans sometimes struggle with because of our capabilities, that does not get distracted, that does not choose to swerve from the lane that it's in when an obstruction comes in front of it, you start to move to a world that's much safer. You start to move to an interstate that's much safer. And for us as motorists, I always tell, because my family was around these vehicles in Arizona, we lived there around them all the time, the predictability of the behavior is what makes the vehicle safer in a lot of these conditions. Now, certainly today, self-driving is not amongst blizzards and snow and things of that nature. I always say in trucking, you shouldn't ever have to teach it how to drive in a blizzard, because the driver shouldn't actually be driving in a blizzard. A self-driving one shouldn't be there. The human is there because we believe we're capable of doing it and because we're being paid by the mile, and that's why we drive. But if you look at any driver on the road, the one thing that I love most when I'm on an interstate driving for miles and miles is I find someone predictable in their behavior. And that is the one thing that makes the vehicle safer around other cars, is its ability to continue to do the same thing over and over and over again. And whether that's dust, whether that's wind, the capability once learned is not lost, and it's replicatable no matter what part of the country you are in.
Very interesting. Thank you. Thank you for giving all of that background. Where does the regulation stand today with respect to, a vehicle going and making a mistake? Because that is one thing that I always get worried about with Tesla.
No, that's totally fair. I can speak very much to, from a full self-driving perspective in the passenger car, it's really state by state. That's, the capabilities that are available out there. That's why you see Waymos in certain markets. They've either technically solved the problem or they're legally able to drive there. Trucking is not a lot different from the landscape perspective, but I would tell you for trucking, which I know the most of, the states that are most friendly of it are in the Sun Belt. Texas, Arizona, Louisiana, along I-10, I-20, up to about I-40. And that's where you'll see the most. All of the truck developers that are out there for level 4 Class 8 commercial vehicles are testing in Texas right now. That's not surprising to me, because for the last several years, Texas has started to put in place all of the regulations to allow it to succeed. It also has stringent requirements for safety, which I think is critically important.
Absolutely. That's very helpful. Are you guys worried about cybersecurity? People trying to just hack into the systems and turning things off, or I don't know, making these vehicles go, and because now these are autonomous, right? Which means all of this is now controlled by software.
Yeah, that's exactly right. And to my comment earlier, not only could you get access to one driver, but one driver is every driver. So our fear is both the attack on the vehicle, but also that attack on the vehicle that can get access to other things within our data set, which includes shipper information, it includes graphical information on the vehicles that we've captured around us. I would tell you that they don't let me code for cybersecurity for a good reason, because it's certainly not a specialty of mine, but I believe, Raju, you have some experience in that. How about your perspective on cybersecurity?
Yeah, well, there's a lot to be said here, but I mean, I see these, whether it is a vehicle or fleet, whether it is a personal vehicle or if it's a commercial vehicle, a truck, or a charging station, I see all of these as computers on street. Okay, computers that are connected in some form or the other. And which means you can go and connect to them and you can make them do bad things. So we've spent a few years ago, we spent a lot of time in my lab where we studied the cybersecurity of smart charging systems, both the electric vehicles and level 2 and level 3 charging stations. And one thing we've noticed is that these were not secure by design, right? Because what they tried to do is they tried to fit they basically tried to put all the connectivity and into a very legacy vehicle, right? That's how these companies really started, right? That was one fundamental flaw, which means, for example, the CAN bus, which is the vehicle's communication system, that's how the vehicle communicates, right? Every signal goes through this something called as a CAN bus, which was designed back in the 70s. And when they designed this CAN bus, they never thought that they would go and connect this to the internet, because internet was not around when they designed this, right? Yeah. So now when you are putting devices on the OBD2 port, and when you're connecting your entertainment system, putting your entertainment system in the CAN bus, and you're connecting your smartphone, now these are all connected, right? Which means the attackers can get into your vehicle, get into the charging station, and send bad messages. So that was one, right? They was not secure by design. It was, but unlike the modern vehicles, they've tried to address that. The second challenge was when they first designed, I think the OEMs, they want to design the most cost-effective product as possible, okay? And when we opened these charging stations, I mean, you have charging stations, at least in the level 2, you can get one for like $1,500. You can get one for $5,000. So we actually opened them, and what we found is that some of this level 2, one of the level 2 charging stations, my students, they found 3 ways to get into the system. Not 1 way, but 3 ways. Right?
What?
Yeah. So they took the smartphone app, they recompiled it, got all the keys, and they were not only able to get into the charging station, but they were actually able to get into the system to steal the customer information, you see. But again, this was 5 years ago, okay? And we worked with INL, and we did not disclose this publicly, but we securely transmitted this back to the company and said, hey, look, this is what we found. Again, when you open the box and when you look at the design, they were using cheap components. I mean, they were using like Arduino boards, for example, right? Which almost every high school student has programmed with it, right? But when you look at some of these really expensive, well-designed charging systems, well-defined charging station systems, they had tamper-proof. They put a lot of thought into secure by design. I mean, they have a coprocessor, right, where you have a secure kernel that is going and authenticating all communications that happens. So these were the 2 big limitations. But I think most companies, both the charging station companies and vehicle companies, they've done a lot of work in the past 5 years to really secure their systems, right? I mean, for example, in vehicles now, you don't have one CAN bus through which all the communications happen. Your entertainment system is now completely separate from all your critical communications that is happening between your braking system, your accelerator system, and so on. So I think we've come a really long way in securing these systems. But now, when you bring in autonomy, when you bring in more sensors, right, especially with the autonomous systems, now you're increasing your attack vector, right, the points of entry, into these systems.
Yeah, and what I'm hearing from you, Raju, is it seems like after you've done the due diligence on installing electric charging or alternative fuel charging, I need to make sure the cybersecurity team at my company is involved too, because they need to understand the risk that I just opened up that may not have been a risk before.
Yeah, absolutely. Because now when you actually bring in AI, there are new threat vectors that come into play. Okay, I think number one is data poisoning, which means if you're training your model on bad data, like maybe some militia actor put wrong data set in that, where maybe they actually put certain stop signs that have shadows in them, and then he goes and changes the data to make the model think that whenever you have that, go at 50 miles per hour, right? You know what I'm saying? So that's pretty serious, right? So that's, again, so data poisoning attacks. You could do adversarial attacks, right, with autonomous systems, which means, see, these autonomous vehicles, they are using cameras and computers to go and recognize the surroundings. Yeah. So some of the researchers have done some tests to where, in a controlled setting, where they've actually put like 50 mile per hour speed limit on top of a stop sign. Surprisingly, the vehicle thinks that it should go at 50 miles per hour. You see? So again, these are some of the challenges that we need to think about. So those are the things that come into play, especially when you bring autonomy, and these are just some of these. So.
Yeah, and something I've also heard in the past is the terminology of zero trust architecture. Certainly newer companies that are fairly recent to the space, it seems like they're building off of a much more powerful platform with all of those lessons learned you just described. Have you seen over the last 12, 24 months companies that are building this into their product, software, or hardware as a core competency now versus an afterthought like it sounds like it was?
Yeah, I think many of the newer companies, if you take Tesla and some other companies that we looked at, yes, they did put that zero trust security and secure by design principles. So the idea of this zero trust security is don't trust, but verify. The idea is the identity of the user, the sensor, the device is verified every time, not just once, right? It is verified continuously. So that's the idea, and yes, absolutely. There are techniques like, for example, 5 years ago, my university didn't have this two-factor authentication. Yeah. Right now, if I just go and log in from a different computer, even though I gave my right username and password, they ask me they do a two-step verification. Either they send me a text message, or I have a Microsoft Authenticator, which actually looks at my face and says, oh yeah, you're the right person, and then it grants me access to this. So it's become easy to implement these now. These are not very hard. Obviously, when you're designing an autonomous system that has a lot of sensors, a lot of connected components, you do have to put a lot of thought into it, and obviously that also increases the cost, right, as well. But yes, I think in the last few years, I've seen companies, make security as a very important requirement as it comes to these autonomous systems. Yes, I'm happy to see that. Although there are newer attacks that are being discussed now, but I think those can be dealt with. So.
Yeah, and I'll have to make sure I implement multi-family member authentication when I get home, because I trust but verify that my daughter cleaned her room. But when my wife goes up, it clearly was not a dual authentication, because it did not happen.